Okay, I think we got something here. Well, hello everyone. Welcome to yet another attempt on doing a live stream and a recording. This is going to be a very interesting journey. I'm going to try to build an oscilloscope. When I was in junior high school, as I explained in yet another experimental video live stream, I built an oscilloscope for my junior high school science fair. It was successful, but it was kind of a kludge because I was too poor. Let me show you something. These rather oddball looking tools, you see, these are called Greenlee chassis punches. They're used to punch the holes you find on radio chassis. When I was a child, I was too poor to afford to buy those. So I had to forage out and find a TV cabinet from the dump with thin wood. I proceeded to make the chassis out of that TV cabinet. With wood, I was able to drill and file the holes for the tube sockets without having to use these Greenlee punches. So it was not the most professional looking piece of equipment, but it did pass muster at the science fair. There was another student who made an oscilloscope for the science fair earlier in my time at McCall Junior High School. His name was Reed Cordeman, and he did it right. He had it on a metal chassis, and the holes in the chassis were properly punched. So I decided, okay, let's reenact my journey in making an oscilloscope, but not for the junior high school science fair, for two reasons. First of all, McCall Junior High School in Winchester, Massachusetts has been repurposed to be the Lincoln School, and the junior high school moved across the street to the old high school, and they built a new high school. Well, that was all explained in a previous live stream. So we can't do that, plus the fact I'm too old for junior high school. So I'm going to do it right here in my humble little abode here in Bellingham, Washington. And I'm going to try to do it right. Now that I have these punches, I'm going to run around town trying to find some scrap sheet steel. If not, I'll have to buy some at my dear friend at Carlson Steel. But the first thing I have to do is I have to figure this out. This is the transformer of an oscilloscope. Now, I bought it on eBay, but the transformer had already been removed from the oscilloscope. The oscilloscope has long gone to oscilloscope heaven. That beautiful Dumont oscilloscope most likely will be waiting for me when I am shepherded by the angels across the veil. Unfortunately, that oscilloscope will probably be seated in the corner of the great workshop in the basement of the great mansion of the angels, because it doesn't have its transformer. The transformer is right here on first earth, not in the seventh heaven. So let me switch to another camera. Oh, let's see if it works. That's going to be camera. Nope. Yeah. Yes. Camera. We're on camera. Whatever. One on the switcher. What you see is the transformer right here. Okay. But a few other important things. Right here is a volt ohm meter. Also, in the far side of the bench, way over there, under the piece of wood, you see a transformer. That's called an isolation transformer. That isolates the circuitry I'm going to be working with from the electrical power main. So if I accidentally touch something I'm working with and touch ground, I should not be electrocuted. The red object you see way over there, that's called a variac. That allows me to adjust the output, the power voltage, going to the unit I'm testing. So when I plug it in, it's not going to be at the full potential of 110 volts. It will start at 0 volts, and I'll start slowly turn that big crank and bring the voltage up. Now, the most important part of this setup is right here. This is a 200-watt incandescent light bulb. What that does is that if there's a short circuit in the transformer, it would not blow the circuit breaker in the house. The light bulb would take the load and light up, okay? Now, that's if there's a short circuit. Now, this transformer, I've already stripped the leads, provided they're not shorted. If I connect the correct power leads of the transformer to the power input, which is after this bulb, theoretically, if all goes well, since there's no load on the transformer, the light bulb should not glow very much at all. If it glows bright, then I know there's a problem or I'm on the wrong winding. This transformer has a lot of wires going into it, which means it has a lot of different windings in it. It's probably got the winding for the filaments for the tubes, the filament for the rectifier tubes, the intermediate voltage for the regular amplifiers, and the special high voltage for the acceleration voltage for the cathode ray tube. Yes, there was a diagram I found on the internet, but showing the colors and what they do. But these wires have faded for so long. This transformer probably was in that oscilloscope the year I was born in 1953. So that's a long time, 53 to 2022. That is 70 years. So this thing's 70 years old. So that is why the colors are fading on these wires. And these wires are very, very stiff, which means they're probably brittle. So without having access to the color code, I'm completely on my own to figure out which wires go to which windings. What I'm going to do is take this ohm meter. This is an ohm meter right here. And I'm going to have to go across every pair of wires and see which wires mate with another one that has continuity with another wire, okay? Now there may be 3 wires that have continuity, which is due to a actually, you know what? I'm going to move the I'm going to make a little camera change. So let's see. Now we can see a little bit better. Now you can see the meter right here and the transformer. I'm going to move everything like so. Now you can see the multitude of wires here and the multitude of wires here, and they're all tangled up under here. Now, what I'm going to do now is a rather tedious chore of going through each of the wires with this ohm meter, and where I see continuity, I will mark that wire, that pair, with a piece of masking tape. Now, I will also check every other wire on the transformer and see if the 3 wires have continuity, which means that if that's the case, that means there is a center tap. And several windings on this will have a center tap, mainly the main supply voltage, or the low voltage amplifiers have a center tap for the full wave rectifier. Some of the filament windings have a center tap to reduce hum with that vacuum tube. So I'm going to try an experiment. I'm going to move the camera to the webcam. Now, we're on a small camera that's sitting right on the bench, aimed down at the transformer and the meter. You know, I have to be very careful because that camera is easy to knock over. So here we go. Now, if you can, I hope you can see it when I touch the lead together. Hopefully, you can see the needle of the meter move. That indicates continuity. So let's try something. We're going to take this wire right here. Now, I think, oh boy, unfortunately, I don't know if I have any clip leads or not to hold the wire on here. Oh my gosh, I may not have any clip leads, but because I probably left them all at the Spark Museum when I was working on the color television. So let's see, this is not going to work. I'm just going to achieve this wire. This wire, I can curl it around the test probe and see if I can make it stay on there without falling off, which probably I can't. So we'll just have to do the best. So this wire, this probe is on the black wire. I'm just going to touch it here. You can see the needle move, okay? Let me get that. You know what? Let me move the camera over there. Now, I'm going to try this lead. See, it moved. Okay, so that means these two wires have continuity. Let's try these two. There's no motion. There's no continuity with these two wires here. Okay, now I'm going to have to go through all those wires over there. Now, what I'm going to do, I'm going to temporarily remove this here, and hopefully without dropping this darn thing in my lap. Oh, let's see, turn this around to get access, all the other leads right here, something like that. Now I'm going to take the one probe and see if I can get it to stay in that one lead which I looped around without falling off, something like that. Now, to make sure that it's got connection, I'm going to go back to the wire that it did have continuity with. Oops. And you can see that there is an indication when I had it. It's not making contact very easily. There you go, there you go. Now let's try all these other wires now. And see if there's a center tap on that winding. Now let's try these two. Nothing there. Hope you can see that. Yeah, nothing there. Nothing there. Move this. Nothing there. Nothing there. Nothing there. Nothing there. Nothing there. Nothing there. Nothing. Oh, whoa, okay, we've got a hit right here. So we get three wires now. We get this one here. And we have this one here on the same winding. I'm going to hold that off like that. Now let's try this one here. Nothing there. Nothing there. Nothing there. And nothing there. Okay. Nothing there. Nothing there. Nothing there. And nothing there. So what I'm going to do right now, I'm going to mark these three wires. Let me double check these. Nothing, nothing there. Nothing there. Nothing there. And nothing there. And nothing there. And now, I'm going to take my trusty masking tape and I'm going to mark those three wires with the number 1, the first set of wires. So it's this one right here. We'll double check it. We're going to mark that with number 1, okay? Like that. That's set number 1. Now let's turn this thing around again. Okay, so it's going to go around. Okay, I can go ahead and disconnect that. Then we're going to turn this around again, something like this. like that. Now, it was, let's see. You can just verify that I've got the right set of wires. So these two wires here have continuity. Yeah, whoops. And that one wire across the side. Okay, so we're going to tape these two wires together and also label them with number 1. Something like this. Okay, so that is a center tapped winding. I don't know what it is right now. We'll have to get to that later. Now, let's take these wires here. This wire here, and this wire here, it's got continuity. So what I'm going to do, just, might as well do it now. I'm going to label this set number 2. Clear out some masking tape. Tape across these wires like this. Okay, and that is going to be section number 2. Something like that. Alright. And then we're going to turn this around one more time. Something like this. We're on the set number 2. So now we're going to take one of the leads of the ohm meter and put it on one of the wires on section number 2 like that, and hopefully that's going to stay there. We're going to verify it by touching the other lead to the other wire that we know has continuity, and it works. Okay, now we're on section number 2, whoops, on group number 2. Let's go on groups of wires. Group number 2, okay. Now, these wires, nope, nope. These 2 wires, nope, nope, okay. These 4 bitty wires here, let's see, nothing, 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 okay. Now, let's see, this here, oh gosh, I gotta reach in there. Nope. These 3, I guess you can't see the meter. This is wrong with that camera. Nope. Nope. And nope. Okay, now let's come over here with these 4 wires. Okay. Let's see, can you see that? Oh, everything's in the way, but yeah. Okay, nope, 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 nope. Confirming, nothing, nothing, nothing. That is still connected over there. These 2, nothing, nothing, okay? Nothing, nothing, and nothing. Okay, so that's a pair by itself. Now this is rather boring. Let's get back to this other camera. How do I do this? I'm going to do, let's see, that is there to here. Well, this is going to be very, very, very boring. I have to ring out this entire transformer and get each wire assigned to a group number. I don't want to waste time doing that and bore you to death. The next time we meet, we're going to have this transformer rung out. That's called ringing out. Then the next thing is to try to measure the resistance of each winding and try to determine whether it's a low voltage winding or high voltage winding. We may end up having to borrow an impedance meter from the Bark Museum to do that. But anyhow, with enough of that, I'm going to have to bid you farewell. And of course, like in all my videos, I conclude by saying, I love you all.